Hello, welcome to Team Navy's group presentation. Our presentation is called Waste Disposal Robots. Our waste disposal robots are designed to tackle the serious issue of trash in our environment, like in beaches, parks, public roads. There are currently limited solutions to tackle all these different environments. Our customers will be the federal and local government and private companies. Here are the design requirements for our robots. It couldn't harm the environment, had to work in both soft and hard terrain, have a rechargeable battery, remotely operated, had to be waterproof, and had to be able to identify trash.
Here we have the robot swarm simulation on the flowchart to your right. Feel free to look at it for a more in-depth analysis, but essentially how it goes is that the robots are going to essentially search the area for hazardous waste and garbage. It will communicate that information to the transporter, which acts as a central hub to share all the information. If the robot meets a garbage that it's not qualified to pick up, then it's going to send another robot who is qualified to pick up that garbage to pick up said garbage. And then after that, once they meet the load capacity, it's going to drop off all the garbage to the transporter, and once the whole area is clear, the transporter's full, then the job is considered done. Here we have the small robot out of the swarm, which uses tracks to move around and ultrasonic distance sensors to know where it's going, but it also has motor mechanisms which moves around the arms and the hands and actually closes the grip for the claw to pick up the garbage. We have the top views and the side views. The original design was that it was going to be flying and use servos for the claw mechanisms, but we thought it wouldn't be as effective and efficient, while the claws with the servos wouldn't be as good as with the claws with a DC motor and a gear mechanism. Here we have the circuit design as the ultrasonic distance sensor finds garbage. It is then going to tell the DC motor to start spinning to then pick up the garbage. And then here we have the activity diagram for how it was going to interact with the swarm, with the transporter. And once it finds the garbage, it is then going to drop it off to the transporter and continue looking for garbage.
My robot is designed to collect large sized trash and it can store large quantities of trash, and because of that, it can operate for extended periods of time and it is water resistant. My robot will receive a signal from a transporter, move forward, and scan for an obstacle or trash. If it's an obstacle, it'll stop, reverse the vehicle, turn the vehicle, and repeat the process until the obstacle is gone. If it is trash, it'll lift the trash over into a receptacle bin, lower the lift, and then if the trash receptacle bin is full, it'll notify transporter and head over to the transporter. If it is not, it'll repeat the whole process, scanning for obstacle or trash. That's how my designs work.
This is the transporter robot. It has large textured wheels for multiple terrains, a large opening to accommodate different size trash, a door that automatically opens, a rain cap on the top to keep rainwater out of the container, as well as a counterweight in the back. Some changes that I had to make to the design include changing the kind of door that it has, as well as the location of the hydraulic cylinder ram used to tilt over the machine to dump its load. Basically how this works is the transporter gets location information from the picker-upper robots in order to go to their location and receive trash. Once the transporter hits maximum weight capacity, it will then travel to the drop location. It will then engage the automatic door motor as well as the hydraulic cylinder ram, which will cause the machine to tip over and drop its load. Once it's done that, it will return to the normal position and then wait for more picker-upper location parameters. This is a representation of the hydraulic cylinder ram working in conjunction with a tilt sensor.
Our robot designs are not new, but the robots that currently exist are limited to the size of trash that they can collect and the environment they can operate. And our robot designs are creating value because they're tackling a serious issue facing the world and they're accomplishing the task effectively. And creating value for our customers because instead of employing a large amount of people, you just got to employ one or two to maintain and operate the robots, saving money for the companies in the long run. Our waste disposal robots work as a team to collect trash from the environment. We realized that actually creating these robot designs was actually an arduous and difficult process, but working as a team did alleviate that. And if we could change anything, is maybe combine two robots to make one that accomplishes both tasks simultaneously. And here are the references. And that concludes our presentation. Thank you for your time.